Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on the upper minus 3 dB frequency calculation of op-amp in a bandpass filter. So in the question, a bandpass filter circuit is given which is based on the op-amp circuit. So it is and the op-amp is ideal. So all the components in the bandpass filter given below are ideal. The lower minus 3 dB cutoff frequency is given 1 megahertz. So in the question it is given minus 3 dB lower frequency. Okay, so FL FL is given around 1 megahertz. Okay, 1 megahertz, and we have to find the upper minus 3 dB frequency. We have to find FH. Okay, and this one is the circuit. So how to encounter this kind of filter circuit? So basically this one is a filter circuit where R and C are in series, and in the feedback R and C are in parallel. So once again this value is R and 10C, 2R and 0.1C. So once again I am redrawing the circuit, okay, and doing one modification for easy calculation. I am writing this R. I am just removing all the R and C value, and I am just denoting this R as a R1 C1 and this as a R2 C2. Okay, just for the simplification purpose. And this kind of circuit is nothing but simply our band pass filter. Okay, and this one is our band pass filter. And if we think about the transfer function, so this one is our band pass filter, and if the transfer function, that is our V naught by Vs. Okay, so the generalized value will come like k times of S divided by S plus omega L into S plus omega H. This one is our some concept. Means this one is the transfer function. Okay, how it will come? I will show you. Okay, but first, means for band pass, this one is S by S plus omega. Second order filter, because two capacitor term are there, so that will come. Okay, okay, after solving. So here, what we have written before this solving of this one, we have assumed that I am writing here. Wait, I have to select pencil first. Here we have assumed that R1 is our nothing but simply R, and C1 I am saying 10C. Okay, R1 is R, and okay, similarly R2 value is our 2R, this one. Okay, and C2 value is 0.1C. Okay, so this one we have assumed. Okay, so once again why I am doing this one, I will tell you. So now what we are doing, I am considering these two resistors. Okay, these two R2 and C2 as a simple impedance, say Z2, and this one I am saying this one is one impedance, say Z1. I am saying this as a suppose Z1 and this as a Z2. Okay, because okay, to solve this function, what I am doing, I will go step by step, means how to solve such type of problem. Means I am saying this one is some impedance, or better to do in a box manner. This one, which makes the calculation easy. This I am saying Z1, Z2, and this one is V naught and Vs. So as we know, this V naught by Vs equals to minus Z2 by Z1. Okay, for example, this one is R2 or R1. It should be minus R2 by R1. Okay, a minus RF by R1. So this one is the concept. Okay, you know the this one is a inverting amplifier. So now this I have told this one is a Z2. Okay, so transfer function we can automatically write. Okay, so Z2, Z1 is there. So what I am writing, Z1 is nothing but simply R1 plus 1 by SC, because one capacitor term is there. So R1 plus 1 by SC1. Capacitor is there, so the corresponding impedance will be 1 by SC1. So I am writing like this. So Z1 is nothing but simply SC1 R1 plus 1 whole divided by SC1. Yes or no? Very simple. This one is our Z1. This one is our Z1. Okay. This whole thing is our Z2. Or we can say this thing we have considered as Z2. And this one we have considered as Z1. Yes or no? So this Z2 and Z1. Okay. So Z2 is R2 parallel with C2. Okay. So this one is our Z1, R1 plus 1 by SC1. For the capacitor, the impedance is like this. Again, what we can do for Z2, I am Z2. Okay. So I am writing here. Z2 is nothing but simply what? R2 parallel with 1 by SC2 impedance. Okay. So 1 by SC2. Clear? So this value will be R2 into 1 by SC2 divided by R2 plus 1 by SC2. Okay. So if you solve this one, we can write as R2 by SC2. I am not skipping any step. SC2 R2 plus 1 divided by SC2. So this SC2 cancel out. So R2 divided by SC2 R2 plus 1. So now the Z2 value is what? Z2 value is, okay, here the Z1 value is this. Okay, so now Z1 and Z2 is there. So what we will write? Now we will write the transfer function. Okay, because here I have already written this transfer function will come like k minus k times s by s plus omega l, where omega l is 2 pi fl. Okay, so once again, this omega l is 2 pi fl, omega h is our 2 pi fh. Okay, and band pass response is there, so band pass will be like this. So this should be a vertical axis, it is v naught by vs, and the horizontal axis frequency, and this point we can say fl, and this value is fh. Fl is given, we have to find the fl is given already 1 megahertz, so we have to find this one. Okay, so before that, this one will be the transfer function kind. Okay, so we have to, now z2 is now known to us, so now we can simply write v naught by vs. Okay, this is the way. If you solve this single question, your concept will be clear. So it should be minus z2. So I am once again writing minus z2 by z1. Inverting amplifier minus rf by rf. So it's simply minus it. So one can write r2 by sc2 r2 plus 1 with minus sign put. Okay, all divided by sc1 r1 plus 1 by sc1. Okay, and if we solve this one, it will come minus sc1 r2 minus sc1 r2, and then this one, what we can write, you can also write 1 plus sc2 r2. Okay, or 1 plus S C1 R1. Okay. So this one is a transfer function in terms of this. Now what we are doing, V naught by Vs, we are writing the numerator as same. Okay. Now we are taking C2 R2 common from the first part. So it should be, one can write S plus 1 by C2 R2 into, if we take C1 R1 common, what we can write, S plus 1 by C1 R1. Okay. Now from here what we can see, this C1 will be cancelled out, R2 will be cancelled out. Okay. So the value of this V naught by Vs can be written as minus S times of R1 C2, okay, into S plus 1 by C2 R2, S plus 1 by C1 R1. So this value is nothing but simply V naught by Vs, we can write as minus K times of S divided by S plus 1 by C2 R2, okay, by S plus 1 by C1 R1, okay. Or one more line, we can write this as a minus Ks by S plus omega L or omega H. It may be omega L and omega H. We don't know, so we have to find. And this should be omega L or omega H. Anyone, so will be omega H, that we have to decide. This one is the trick, or we can say the concept we have to think. This one is a very interesting question. Okay, so now this one is our band pass filter. If you solve, it will either, it should be S plus omega L. This may be omega L or omega H. Okay, means it should be the transfer function, means this value will be minus Ks divided by S plus omega L and S plus omega H. But which term is our omega L or omega H, we don't know. Okay, means it should be C2 R2 or C1 R1. So that we have to think. Okay, for this purpose, and here this K value is our minus 1 by C2 R1. Okay, so now first think about 1 by C2 R2. So 1 by C2 R2 is there. Okay, so 1 by C2 R2 we have to find. So now everything is known to us. From here, the R1 value, R1 equals to R, okay, and C1 equals to 10C, R2 equals to 2R, and this one. Okay, so once again, so I'm just again redrawing the circuit, that this value is our R1, C1, and this one is R2 and C2. Okay, so now C2, R2 is we have to find. So C2 value is 0.1C and R2 is 2R. So what we can write, 1 by C2 is 0.1C into R2 is 2R. So this, if we solve, 2 by 10. Okay, so if you remove this decimal, 10 will be go up by 2 RC. So if you solve simply 5 by RC, it is coming. Okay, and one more thing, 1 by C1 R1. Okay, sorry, miss, there is means C2 value is 2R, sorry. Okay. No, it's 1 by C2 R2. Okay, 0. Okay, same. Okay. Now 1 by C1 R1. So C1 is 10C into R. Okay. So it will be simply our 0.1 by RC. So now which one is greater? 1 by C2 R2 is greater than 1 by C1 R1. So we can easily say this value is nothing but simply our C2 R2. The value of C2 R2 will be our FH. This will be the FH. And this will be, or simply say, this will be our omega H, and this is lower value in comparison to this. So, okay. From these two, what we observed that this value is our omega H, omega L, because this value is 5 by RC, 5 by RC is greater than 0.1 RC. So now we know the which one will be omega L. So this value will be C2 R2 will be, okay, now V naught by Vs. So 1 by S plus 1 by C2 R2. Okay, minus K times of S into 1 by S plus 1 by C1 R1. So from this one, okay, we can write V naught by Vs minus Ks, no need to worry, S plus 1 by C2 R2. So it is nothing but simply omega H, and this one is S plus omega L. Yes or no? This one is the trick. First you have to derive this one in terms of RC. So we can say this one value will be, sorry, this one will be omega H value, and this one will be omega L value. Okay, now we have to find omega H, omega L. So in the question, FL value is given 1 megahertz. Okay, and omega L is here. Omega L is 0.1 times of RC. Yes or no? So this omega L is nothing but simply 2 pi FL 0.1 RC. Okay. So one can find the value of RC as a 0.1 by 2 pi FL. Yes or no? RC value is also unknown. So we are writing in terms of FL. So it should be 0.1 times of 2 pi, and FL value is 1 mega, means 10 to power 6. Okay. So the value is this value. Yes or no? Now we have to find the value of FH. So I am using this space. So for FH we have to find, and omega H value is nothing but simply 1 by C2 R2. So one can write 2 pi FH equals to 1 by C2 R2. Okay, so 1 by C2 R2 is nothing but simply 5 by RC. C2 R2 is nothing but simply 5 by RC. From this expression we can write 5 by RC, C2 by R2. Okay, 5 by RC, C2 by R2. This one is our C2 by R2, 5 by RC. So now FH value will be 5 by 2 pi RC. Okay, so 5 by 2 pi RC we have to find. Now RC value is known to us. RC value is known to us. Means this would be 5 by 2 pi into RC value is what? 0.1 divided by 2 pi into 10 to the power 6. So these 2 pi will be cancelled out. So 5 by 0.1 into 10 to the power minus 6. And if we remove this decimal, it should be what? Okay, it should be plus 1 by, okay, it should be go up. So 10 to the power 6. So it should be 2 pi 0.1 2 pi into 10 to the power 6. So it should be 50. Here it should be 10 to the power 6. So it should be 50 megahertz. So FH value will be 50 megahertz. So this is the problem, solution of this problem, 50 megahertz. But first we have to identify which one is omega H. Okay, so it is already clear that from the diagram FL is 1 mega. So the value of FH will be 50, 50 megahertz, and this one is nothing but simply 1 by 2 pi RC2, R2, and this one is 1 by 2 pi R1C1. The lower cutoff frequency is divided by 2 pi RC1 that we have derived and we have find from this. Okay, so main thing is you have to know little bit about the transfer function, then you have to write this expression. Okay, then we have nothing, we have just solved. Okay, R2 by R1, and after calculation which one is omega h we don't know. So then after we have to decide from the data, means 0.5 by RC, so it should be omega h because this one is bigger. So omega h, omega l, then 1 by RC value is there known to us now from this expression. Okay, fh is there, we have find the value of 1 by RC value. Okay, we have find the value of this. Okay, RC value. So now 2 pi, this value is fh 5 by 2 pi RC, fh 5 by 2 pi RC, then we have to put the value of what, RC. So RC we have put it here. Okay, I will show you also. RC we have put it here, clear in this side, RC. So then it will come 50 megahertz. So this is all about the gate question for the upper minus 3 dB cutoff frequency calculation. So this was a very interesting question. So thank you for watching this video. Thank you.